Hello everyone, welcome back to more Advent of Code 2020. I almost said 2016, just because I see the number 16 here. No, it's 2020. We're doing day 17 today. Day 17, Conway Cubes. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau, the MIB, Men in Black, is that the joke today? I don't know. Anyway, contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. At every integer three-dimensional coordinate, xyz, there exists a single cube which is either active or inactive. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is a small flat region of cubes, your input. The cubes in this region start in a specified active or inactive state. And then it does 6 cycles. Each cube only ever considers its neighbors any of the other 26 cubes where their coordinates differ by at most 1. So it's basically a three-dimensional Conway's game of life here. The name Conway Cube, of course, referring to that. All cubes simultaneously change. If it's got exactly 2 or 3 neighbors active, then it stays active. If it's inactive, but exactly 3 are active, then it becomes active. So it's sort of like, if the number what is 3, then it's always active. If it's 2, then it stays the same, and otherwise it becomes inactive. Fine. And so we're just meant to run, and this is an infinite cube. It starts out in a small region, but gets larger. So this, I guess we don't even really have to model it as a cube. We could, I suppose. But you can model it as like a plane that expands into like a rectangular prism. Anyway, so we're supposed to, at least for part 1, we're supposed to do 6 cycles and then count how many are active, I think, right? Yeah. So I did, as I often do once it gets to be later in the season, I did read through this before I started recording just to make sure that I'm like sort of ready. I haven't like written any of the program or anything, but I had some thoughts. The first of which is like I should just get over myself and relearn how to use arrays. So I went back and looked at a few things. Because obviously this would not be like horrible as a map from triple of int to int, or an int map to int map to int map of int or something, or int map of bool, whatever. But it kind of like is not ideal. And performance might matter a little. And anyway, it'd be nice to learn how to do this. So I went back and looked at 2018 and found a program where I used arrays. You just need the array library as a dependency. And then in main, there's a bunch of functions to import. But the ones that seem to matter, I think we'll use st because why not? St array should be perfectly fast and simple enough to use. And all we really need is like we need an st array, the ability to create an array, read arrays, write arrays, and then read arrays like indexing into it, and get a soaks is a way to like get all of the key value pairs out of an array. And then we just need the st stuff for run st, which is simple enough. You can just treat st like IO, but it has different operations. The thing I wanted to check was, like, what are the dang types? That's the hardest part. St array's type is just blech. But it's actually, like, not that bad. Alright, I looked at it, and like, the type's not that confusing. It just, like, needs to be parameterized by s to be available in st. Anything in st has a phantom type parameter that you're not allowed to look at to allow... It doesn't matter. The type parameter is there so that the type system can prove that you are not leaking mutable values out of st. I don't totally understand how it accomplishes that purpose, but that's my understanding. You are required to carry around this type parameter that you can't ever read, and that's how it can prove that you never leak anything. And then it's got an index type, so arrays are not just indexed by int. There's a type class for anything indexable. And of course, int is indexable, but also a tuple of any 2 things that are indexable is indexable. And in general, it's extensible, so you can make anything. Basically, indexable is just like, is there a way to turn this into an int and vice versa so that you could treat it as an array? And then the value that is stored. And we want stuff data array st. And I think we might as well use an unboxed array for performance. We're not like going to need it to be lazy or anything. So unboxed arrays is an stu array of s, index, and e. The same thing. Okay. And we can use... Does it have bool? It has bool. So perfect. That's all we need. We'll use a bool for whether it's active or not. And then we get the marray interface as well, which is exported by strarray. We have new array, which we looked at, and we would initialize it all to false or whatever. Oh, new list array gives the elements of the array in ascending order beginning with the lowest index. Yeah, that might be a good idea. That actually is a good idea, actually, because then we can just take the input, and as long as we index it in the way in a way that is consistent with its orient. Anyway, doesn't matter. I think we can just pass it a new list array of all the booleans and collapse our n lines into a single one long line, and then they'll just all be in the right order. We read and write map. Do I want... Oh, this sounds very useful. Yeah. We don't need read and write. Because, like, I was thinking we would each tick, we would create a brand new array rather than trying to somehow be super fancy and write over the existing array, right? Because it's hard to coordinate that to all happen at once. And then I was like, oh, well, why don't I just use map array? But our grid is going to be getting larger as the cubes propagate out into space. I guess we can just allocate a single array ahead of time that's large enough. Right? What's the new array? How do you... So you create a new array. Okay, so indexed, all right. It's a little weird because I don't know how to, like, it would be nice if we could handle 0, 0 being the center. But I guess we can just do a translation so that if we make the array big enough to start and then shift all our initial stuff, like shift everything, like say our array was 13 by 13 or whatever, we could shift everything by +7. So the square at 0, 0 is at 7, 7, and the square at like -1, -1 is at 6, 6, and that would be, then it would all be centered, and we could actually use arrays of the same size, and then just use like map array, or map indices, I guess. Applying a function to each of the indices, is that right? It takes... What? It takes in a pair of indices. What is this? Y? A function... Oh, does it actually let you transform into an array of different indexable type? It looks like it does. Oh, I see. This is not like map where you get the key and the index and the value. This is letting you say translate this into a different coordinate space, basically. Because you say, I have this array indexed by j, and I want an array indexed by I with the same elements. And here's the bounds of the I array. And you can map all the... Oh, so we can even use map indices to do the initial transformation. That's interesting. But actually, I think we don't have to do any weird translations, because when you make an array, you not only specify the type of the index, but also the bounds within the index. So because int is indexable, we can say, I want an array of ints where the min bound is -7, -7, -7, and the max bound is 777 or something like that, right? And then we could just is that what we want to do? I guess so. Centering it all on 0. Anyway, then we could map array to produce a new one that's the same exact size, and just look in the old array to decide how to do stuff. And I assume this will all be very efficient because we're doing it in st array. And unboxed, by the way. I guess we could specify int 8 for efficiency. Sure. And then last, I just wanted to look at run st, which is really simple. It's like all you really need is run st, where you say, I have an st computation, please give me the value. And here's where you prove that you can't possibly use the type. You have to say, whatever you're doing with this st, you have to be able to do no matter what type I give you as s. And that sort of proves you can't ever depend on the value of s. Okay, so I added array to our dependencies here, and what I should have done, but did not, is stack build ahead of time to make sure that it gets array. But it looks like it was already fine. Cool. All right, so I guess now we can get started. Let's add some imports. Import data array st, and we kind of want like a lot of things, so I'll just I'll write them all at the top so I can remember what it is that I want. We have an stu array, which is a type with no constructors, and I don't think we need run stu array. We just want the stuff from marray, which would give us, yeah, get a soaks. Okay, but that's re-exported by st, and we need like map array. Probably it's useful to have write array and I just realized something I was imagining we would do, but that doesn't make sense. I was saying, oh, we can just use map array and pass it a function that looks at the old array to decide what should go in the new one. But you can't. Because that's not a function. You can't read an array, even inside of st, without declaring that the result of that type is itself st. And so we don't have a function from e prime to e. We have a function from e prime to st of e. And so map array won't actually do what we want at all. We're going to have to do like read array and write array ourselves, which is like no big deal. And that means we might as well resize the array every time rather than creating one that's large enough. Read array, write array, new array. Okay. Anything else I'm missing here? I don't think so. And in import control monad st of st run st are the two things I think I need from that. Yeah. Okay, cool. So now what we want to define is a type that's our cube. Let's say cube of s, because we're going to need to keep the type parameter for st around, I think. Well, actually, let's type coord, let's say, is a triple of int. We could say int 8, I guess. But I don't really want to type 8 over and over, so let's not. And type cube of s is an stu array of s, coord, and bool. That type checks, great. Honestly, looking through the documentation for st array, I found it a lot less confusing than I remembered. I wonder if it's vectors that are so fucking confusing, or if I'm just like misremembering. It's not like convenient. It sucks to work with indices and stuff. It's one of the nice things about working in functional programming. You don't have to do that very often. But okay. So now I think we want like we want like a function, let's say called tick, which I don't know. Let's go look at our input, by the way. How large is it? It's not very large. 8 by 8? Yeah. Tick is a function from cube of s to st of s and cube of s, where we compute the next cube based on the previous one. Oh, you know what? We're going to need to look at the bounds as well of an array. Get bounds, I think. Oops, too many parents. Because we're going to need to interrogate the bounds of the existing array. And then make a new one that's slightly larger. Yeah, okay. I was just briefly imagining it might be nice if this were like a mono functor, so you could just like map successor over a tuple of coordinates and have it increase all of them, but that's way more work than we need, so let's not. Mono functor, is that even a thing that exists? Probably, right? Let's look that up. Haskell mono functor? Mono traversable. Yeah. It's for things like functor, but which aren't allowed to change type when you map them. Yeah, where you would declare, okay, the element type of this is int, and anyway, so we could do that, but I'm not going to. It's really not worth it to save the effort of having to write, you know, +1 3 times. -1 3 times as well, I guess. Anyway, so tick of cube equals, might as well just open a do right away. What do we want to call the size parameters? I want to call them like x, y, and z, but we're going to use those to refer to actual indices, right? And so I want like width, length, and height. Seems kind of gross, but to come from get bounds of cube. It's just telling me that I can't bind there, right? No, what's wrong with this? What? Oh, right. Because actually we have the bound, we have an index of 2 things. So x min ymin, zmin, xmax, ymax, zmax. There you go. So that type checks. That's how you get the bounds of the array. And we need to make a new one. I guess we'll just say let. Oh, this is so horrible. Size as xmin prime, ymin prime, zmin prime. Oh. Equal xmin plus 1, or no, minus 1. Put this on a new line here. Ymin minus 1, zmin minus 1, xmax plus 1, ymax plus 1, zmax plus 1. There you go. It's just mag for ending a do with a let. Don't let that bother you. In fact, let's just let's shove an undefined in here so we can work in peace. It highlights the of those, but at least they're yellow. Now we need to create a new array. Cube prime comes from new array size, which really we ought to have called bounds. I don't know. And then we have to initialize it all to false, I guess. Yeah, that seems okay. What is it upset about, though? It doesn't know what type bound we should use for S. Isn't the whole point of this that it like runs inside of ST? Like, shouldn't it unify with the ST we're returning? An M array of some type bool and STS. Okay, what do those correspond with in M array? A, the underlying array type. Oh, is it? No, ST array. We have run ST array. Unboxed array. How do I make one of these fucking things? All right, let's see if I did it here in 2018. New array. I mean, this looks like the same thing as what I'm doing, right? I run st of do, but that's fine. I think. Or is the problem that st is so confusing? We could just use an IO array, but I don't really want to have my entire computation embedded in IO. I don't quite understand. Like, I could write this if I added rank n types or whatever it's called. Yeah, like, I don't think this actually resolves the problem. Oh, hang on. Language rank n types Like, this doesn't actually help. Data array base M array. Yes, that is what I want. Oh, I bet it'll figure out as soon as I try to return it, right? Suppose I said pure cube prime. Okay, that's the problem. It said you made this array, but you didn't tell me how it was going to be used, so I couldn't figure out what type it was supposed to have. Got it. So now I think we can where the heck is stuff like 4 underscore? It's in my last year's thing, right? Control monad has 4M, which I don't know. I guess I just want like traverse or something. Let's just look on Google. 4. It's in data foldable. For oh geez, I have to write like let indexes equal do. Now there's gonna be a do in the list monad here. X from x min, x max, y min, y max. This is so dumb. Why is this a do? Lift A3. Lift A3 is what I want. The function that makes a 3 tuple over and it feels even dumber because like I know zmin. Well, actually they'll be different, won't they? Zmin prime, z max prime. We need to import from I assume it's in applicative? Yeah. So now we have all the indexes that the new array is going to have. And we can say for indexes lambda x, y, z do. Does this parse right, by the way? Or do I need parentheses in here somewhere? Oh, it looks good. Okay. So now we're going to perform a computation involving a stateful computation involving x, y, and z. I mean, honestly, I could inline indexes, I guess, if I wanted. It's kind of an interesting idea. How long does this line get if I do that? Totally manageable. Well, barely. What are you? Oh, I didn't get rid of that line. Sure. So what we need to do then is find the neighbors of x, y, and z. And we need to write like that. Let's define neighbors of, gosh, do I need, I think I need 4 as well, right? Like without the underscore? Does that not exist? 4M probably? I guess it's just traverse basically, but taking its arguments in a different order. Oh, traverse will be in here? Data traversable, right? Actually, it's just in base. Anyway, neighbors is a function that takes a coord and returns a list of coord. We've written this before. Neighbors equals tail of oh man, are we gonna be super fancy? This is dumb. This doesn't make any sense. I was thinking of using iterateM 3 to choose from the same thing twice. Maybe this is fine. Tail of XYZ for XYZ from this time it's a list though. We're converting from a 3 list into a 3 tuple. Replicate 3 of 0, -1, 1? Okay, from control monad. What I wouldn't give to have like an IDE that could just tell me where that shit comes from, you know? That's certainly one thing I appreciate about where I work is really, really good IDE support. You know, it's in Java, so it's not a big surprise, but it's a pretty big code base, and it's nice to, it just like so much stuff happens automatically. Okay, so this is obviously not finished, but why? We replicated 3 times the choice of 0, -1, 1, yielding a list of 3 lists, a list of lists each of element 3. And then we said for each such list, turn it into a 3 tuple, and we called tail on that. That seems okay. Oh. Right. This is just the list of deltas. So what we actually want is call these dx. There you go. So that's how we compute the neighbors of a cell. And we can test this easily enough in our REPL here. Like if we said neighbors of, well, easy enough. Let's say 1, 1, 1. I said, well, 1, 1, 0, 1, 1, 2, 1, 0, 1. Importantly, we never got 1, 1, 1 again. That's what the tail was for. We got everything else. All combinations of 0 and 1. And just confirm if we said length of that, there should be 26. 26, great. Okay. So now, back to tick. We have a set of neighbors, and we kind of want to... Well, we don't have a list of neighbors. We have a list of all the positions we want to write values to. And so for each such thing, we need to compute the sum of all the We need to map over the neighbors. Okay, let's just write some stuff and try to get it to look pretty in a minute. Let ends equal neighbors of. Oh, actually, we don't want. Let's just say lambda coord. So then we want to map something statefully over them. Living can't be in a let for doing it safely. Living traverse, which is like map but monadically. We need a function that takes a single coordinate and looks it up in cube. That's easy. It's read array. What order do you take your shit in here? The array first, so that's perfect. Cube of ends. And then we just want to pure of sum living, is that correct? No, because... Right, there's a lot of reasons this is wrong. First of all, Booleans aren't summable. But actually what we want to do is not return pure, but mutate the old array. So we want to write array which takes the array first, cube prime, and then the index, which is coord, and then the value, which is should live. We need to read the existing coordinate too. Current read array cube coord should live cur filter id living. And we need to implement should live, which is simple enough. Should live is a function from bool int bool should live alive num living neighbors equal case num living neighbors of 2. Then wait, what am I doing? Yeah. So if let's go review the problem statement here. If there are 3 neighbors, then it becomes active whether or not it was before, and if there's 2, then only if it was alive before. Otherwise, it dies. Okay. So this all type checks, but I do not yet have the facility to like determine whether it's correct in any meaningful way. It would be nice to like tick a very, very simple cube. Like, we could do this in the REPL, right? Oh gosh, it sounds hard. Running ST stuff in the REPL where everything is like one line is just awful. Honestly, we could even, instead of using new array, we could use like new empty array, whatever the thing is that doesn't write any values in and says you better not look at them, they're undefined. But whatever, we'll just use new array. It's fine to write a few falses in. But what I really want to do is test this. For example, on a simple 2x2x1 array with exactly 2 cells, it should get, with 2 of them set, the ones that are set should stay set, and the ones that are dead should stay dead, right? But it should get a bit larger. And if we set 3 of them, it would be more interesting. So maybe we'll write a little function. Maybe we won't write a little function. We'll just call it a test. Test is an IO of nothing. An IO of a list of pairs of chord and bool, and we'll just look at it by hand. Test is run st of do. There you go. Cube will be make, what's it called? New array. New array of, it'll be a function from list of pair of chord bool to, there you go. So we'll just feed it a set of coordinates by hand, and it'll give us the new one. Well, ugh. But then we have to compute the min and max bound. That just kind of sucks. Let's just do this by hand here instead of trying to make a general function. It'll be a new array of 0, 0, 0 to 1, 1, 1. You'll have to forgive some of the, I make weird typos sometimes instead of typos normal people make. Like, why would I have accidentally, maybe I haven't done it today, but like, I'm typing a 1 and then I type a, you know, a 0 instead of a closed parent or something. I've mentioned in my previous programming videos, but I think not this year, that I swap on my keyboard layout the number row with the symbol row. So like I hit an unshifted one to get an exclamation point and a shifted one to get the number. It was a bigger win when I was writing Clojure instead of Haskell and Java, but I think it's still fine. Like, when do you ever really type numbers? When I want to type numbers, you know, I use the numpad, right? In functional programming, you don't need numbers all that much, right? Not as often as you need weird symbols. And I certainly have written a lot more dollar signs than I've written 4s, so, you know. And parentheses, obviously way, way more common than 9s and 0s. But it does mean I make different typos than people. Anyway, so new array... false, yeah. For, we still have to say, oh yeah, right. For, and I'll just give it the list of things that should be set, like 0, 0, 0, and 0. We'll say the high order, oh, hang on. We can do this because we're actually building a 2D plane, a 2x2x1, or 1x2x2 in this case. I guess for that reason we should make it 1x1 or 2x2x1 in this way. So 0, 0, 1 to 0, 1, 0. We'll say these are the things that should be set. Right, what are they? Right array cube. But we need to flip and write true to it. Yeah. No. Oh, is it? Well, No, it's mad about... I'm not sure, actually. If I said undefined here, is it just mad because I haven't lined up the return type properly yet? No. So flip right array of cube. Right array of cube. We've handled by calling right array and passing it the cube. We've given it this argument. So we have I to E to M, but that's not what we want. We want to apply true to it. So we flip it. Now it takes E to I to M. We apply that to true. This looks right. Why is this not right? Oh, the flip goes outside the parentheses. Flip, there you go. And yeah, it doesn't know what... Really? Oh, it doesn't know what state to use because we haven't returned this. Maybe? No, it doesn't know what index to use? Doesn't know what array to use? I'm a little confused. I think it'll go away when we say pure cube, but like, actually that's the wrong thing. So we want to say is, how do we get a soaks? Like, what's the deal with that? It takes just an array and return. Okay, so we say then get a soaks of cube, and like that's it. List of... Wait a minute, what's the type of run st? What is the type of run st? I guess I better look at the docs, huh? Oh, it doesn't even need to be an IO. Right, of course, that's the whole point. Got it. Okay, so is it just this, right? It's still upset. Why? M array, it's not sure what the array type is, right? But shouldn't it be? It's an STU array. Oh, or is it not? Maybe I'm using the wrong new array function. No, new array. Oh, I forgot to tell it the coordinates that we want. No, this is right. I said from 0, 0, 0 to 1, 1, 0. Those are your coordinates. And I gave it an element to initialize with. This is correct. I don't understand what's wrong here. Like, this, by the way, is not even running my tick function. It's just... creating an array, writing two values to it, and then producing that array. So I wanted to make sure I understand what's going on in ST, and I clearly don't. new array, and returns an M of array of I and E. But it doesn't know what the array type should be? Do I have to say that it should be an M array of STU array or something? I guess that's a good point. Where am I mentioning anywhere that I have an STU array? I see. I have to tell it I wanted it to be a cube. Let's put it here. Type signatures can't go there. How? Okay, hang on. What we can do then, I guess, is say here, cube is of type cube. Now leave me alone. Cube of S, where I don't know what S is. Yeah, type variable would escape its scope. That's the trick. I'm trying to not let it escape, though. Jesus Christ. How do you run ST on anything? It's so baffling. What did I do last year? No, not last year, 2018. So I said run st of do, new array, and I did some stuff to it. Then I said get a soaks from it. Then I made a set from those associations, and then I ran some function based on that. Huh. And for some reason I needed to annotate this as returning a coordinate. Because I was printing it, I had to say what type it should have. Okay. How do you get anything? I mean, ambiguous type variable. Add a type annotation, but I don't know what type. I can't, right? It's like it's illegal to mention this type. It's of type like for all S. STU array S coord bool, right? But I by adding this for all, I broke everything. So I love, by the way, Emacs's region-specific undo buffer. What I did there was I highlighted this region and said undo the latest change that happened in this region, which I remember was me deleting rank and types earlier. Anyway, back to real life. Okay, this is exciting. We have a new error. Couldn't match type. Oh, it's actually an STS of this? Capital T. Yeah, okay. So we had to say this value that we're binding is a stateful value of some type that we don't know, containing an STU array of S coordinate and bool. Okay, and probably like it all would have been fixed if we had just like eventually called tick. But what is it warning me about here? Oh, just a redundant bracket. That's true. Well, never. I like the bracket. So if we were to in our REPL here say what is test? 0 0 true, 0 1 0 true, 1 0 0 false, 1 1 0 false. So that's what we hoped it would be. Now what I actually want it to do though is to say cube should be tick of cube. And tell me about cube prime, please. Error in array index. Well, fuck me, right? What error? Oh, we're not going to use map array, right? So, fair enough. Traverse read array cube of all the neighbors. Xmin prime to Xmax prime. And we created bounds to be min minus 1, min minus 1, min minus 1, max plus 1, max plus 1, max plus 1. We labeled them all correctly. This looks fine. I mean, not that it super matters, but I guess it actually is a bit nicer to put ends there, so it's closer to the line that uses it. And I guess we could actually put cur here, so it's also close to the line that uses it. I just have like no idea how to debug this is the problem that I always run into when I do anything like complicated in Haskell that isn't just dealing with pure values. We can use debug trace and just like print shit. I mean, I guess I might as well. And I forget how you use trace show. Yeah, and okay. Trace show. I don't know. Let's honestly just look at each coordinate we're deciding to write to, I guess. Trace show coordinate, like so. So now it should print each coordinate in the new array that it's considering writing to. -1, -1, -1. That seems valid. It should be allowed to write there. We made the array bigger. Oh! No. Ah! Of course. The problem is that we want to write to a new thing, which is -1, -1, -1, and that's fine, and that's in the new array. But to compute the value for -1, -1, -1, we look at its neighbors, including -2, -2, -2, which does not exist yet. Okay, so let's look up the... what is the deal with this index type? What can I learn? Oops. I can learn in range, right? Yes. So what I want to do is, before I look it up, check that it's in range of the old array. Got it. So that'll be in import data ix in range. And that goes here. Old value cube. I guess what we'll do is we'll let old value be a function here. Old value of x, y, z, old value actually of c is in range bounds c is read array cube, the old cube of c, otherwise equal false. Pure false. I will turn on flexible context. I don't know what it does, but I understand it's generally harmless, and it does seem like I'm doing something a little bit unusual by defining a function with this weird phantom type variable in the middle of do notation on st, so sure. Let's let it have a weird type, that's fine. Okay, oops, wrong. So if I now run it, still wrong. And again, the value, when we call read array, that might also be wrong. So instead of read array cube coord, we'll say old value of coord as well, right? Still wrong. I hate you so much. Okay, let's trace. How does trace? Fine, I'll add it up here. And its type is, I know, but like, let me see its actual type. Data, debug trace. Trace? Takes a string, yeah, unsurprising. Reading old. Show C. It says reading old of -1, -1, 0. Oh, I'm looking at the old bounds. Okay, I knew there was some reason I should have called this bounds prime instead of bounds, right? I was just checking to see, are you in bounds of the of the new array before I looked, and like that was not helpful at all. And what I actually want is here. Oh, you know what? I can actually lift this up before I define the new cube. Like so. And then it's a bit clearer that it doesn't depend on the new cube at all. Okay, so now we got a new cube that's like huge. It should be 3 by 3 by 2, so there should be 18 of them. Oops. 48. Oh yeah, not 3 by 3 by 2, because it got bigger by 2 in each dimension. It went from 0 to 1, 1. So okay, so it should be 3. No. 4 by 4 by 3. That's 16 times 3, which is 48. Okay, cool. And it should have how many truths? Just 2? Oh, there's 0. I don't like there being 0. Why aren't there any? Ah, well, we got a bunch of prints about it reading the old values, which makes sense. And what are the ones that we actually initialized to 0? To be true, I mean? 0, 0, 0, and 0, 1, 0. So this one, it looked at these two cells. Actually, several of them should have. All the ones that were in the original should have been near there. Oh, hang on. No, I think this is right. I made an incorrect conclusion about how this would behave. Yeah. This is right. If a cube is active and 2 of its neighbors are active, it stays active. In our test example, we had only 2 active cells, so none of them had more than 2 neighbors. Got it. So if we make a 3rd active cell in that region, they should stay active, right? For example, 1, 1, 0. And actually, we should get 4 truths. Well, we should get maybe a lot of truths? The 3 original ones should all stay true, stay alive, because they all have 2 living neighbors. But also, everything that is in their general vicinity now has 3 living neighbors and springs to life. So let's try that. Oh yeah, look at that. There's so many truths. 1, 2, 3, 4, 5, 6, 12. I don't know. That number seems plausible. It's a multiple of like 3 and 4. Could be true. Okay, so now I'm like reasonably happy that our tick works. I have trace show in here somewhere, don't I? Yeah, there we go. Okay, now I think there's something called iterateM, but it's in like some weird library maybe. iterateM. Yeah, like nobody ever put iterateM in a popular package. It's like it's in like Monad Extras, whatever. Because it would be nice to say just run this 6 times, right? So I don't know, like why don't I just write it? Maybe here. iterateM takes for any monad an int and an MA and returns. Ah, right. The reason is that iterateM normally would not take an int at all. It would just return a lazy list of values, which is difficult to do in a monadic context. Sure. But since I have, isn't there something like, I don't know, let's suppose, Hugel, that I have a monad, right? Monad M. And I want a function from int and MA. I also have, furthermore, a function from A to M of A. And then I have an MA, and I want out an M of A. Is anybody giving me one of these? Do these exist? It's still loading. I don't know why it's taking so long. No results found. Suppose that, so you could probably, like, I don't know, this might give you something. Bind, yeah, very funny. Okay, fine. Well, that's like fold map, which we could maybe use. Fold map M. Ugh. Okay, whatever. We'll just write it. Takes an int and M of A, and an let's write it in this order: A to M of A, M of A, and give me back an M of A. Iterate M0 of X is just of 0, and F and X is just X. Iterate Mn of F and X equals iterate N minus 1 of F and X F? Okay, sure. So now we have our iterate M. And if we said test, if we said iterate M2 tick over cube, this fails to type check for some reason. Why? Oh, well, I don't have an M of A, I just have an A. Yeah, that's true. So I guess it should be typed like this. Pure X. And then we write F of X, iterate N minus 1 F? There we go. That makes more sense. We loaded this. Now go back to the REPL and write test, and it's much larger. And for some reason, only 3 of them are alive now. I don't know. That could happen. Sure, why not? But the point is, it's going, right? So okay. And now I think we can just write like our parser in part 1. It's been kind of a slow puzzle for sure. This was, you know, we were playing with types that I didn't really understand that well. It totally makes sense that it would take some time. But our input, I think, it can't really be a cube of anything because that's in ST, right? We have an STU array, not just a U array. So we'll just make it, I guess, a list of... We'll make it return the bounds and the elements that should be written, and then it'll be the job of both part 1 and part 2 to create their own arrays, I suppose. So part one is a tuple of I don't know. Let's just make it a 3-tuple coordinate. Well, no, it's nice for it to be split up coord, because that's what we're gonna pass to new array is the pair of coordinates, right? And then also a list of pair of coord. Actually, that's it. Just coord. We don't need to say true or false. We can just like only write the true ones. Okay, cool. So prepare. We kind of need to actually parse, not parse, but like we need to run over the input multiple times to figure out what size it should have. I don't know. Prepare s equals let lines equal L's equal lines s dim equal length of head L's, let's say. Yeah, and then we can just say bounds is so we're creating the bounds, which goes from 0, 0, 0, which we'll call the top left corner, I suppose, to dim minus 1, dim minus 1, 0. And then we will return bounds and do. I should just not think about what the dimensions mean and just do the natural thing and it'll come out okay. X, C. Wait a minute. Can I just like, what happens if you fail a pattern match in the list monad? Do you just get like, it skips to the next one? Probably not, right? Maybe it does. I don't know. We'll find out. X hash. No, this is stupid. That doesn't even make any sense. We'll just X line from zip 0 L's Y char C, I don't know, zip 0 line, guard that C is a hash. We'll import guard in a moment, and then return purely the tuple x, y, 0. Okay, so this type checks. Part 1 of bounds alive equals. Do we just want to jump into ST immediately? We probably do, right? We gotta just make the array and write to it equals do. Cube comes from make array bounds false. For You know, like, this almost seems, this pattern looks reusable somehow. Because up here, I'm not really reusing it, right? I don't know. For bound and bounds, let's say, right, yeah, let's just lambda c. This way we don't have to write the weird flip thing. Write array cube c true. This is honestly better than what I wrote up here with this flip nonsense. Lambdas are not the enemy. iterateM 6 tick cube. And there's some way to get not just the assocs, but not all the assocs, but just the values, I assume. In data array somewhere. Get elms? Sure. Pure, no. Length filter id over get elms cube prime, which we have to get from get elms. Now, why are you fucking bugging me about this again? Make array. It's called new array. All right, fair enough. You got me this time. What? Why are you mad about... Statement of a... Expected type int. Oh, I forgot to say run st. Alive is wrong. Thank you. This should be alive. Wow, why did bounds work at all? Oh no, it's because tuples are foldable in a totally... Oh man, I'm one of those people who always says, oh, it's fine that tuples are foldable. It's so useful on occasion. No, today it was not useful. Oh boy, okay. So what happens if we just like run part 1? Stack run. Do we get anything good? $267. Okay. Could be. That's the right answer. All right. You know, it was a long process to get here, and I was never totally sure things were working, and we had to do some debugging and stuff. But by golly, when the final program actually, the first time we tried to run it, it was right, which is kind of nice, I think. Actually, let's do a little cleanup here. We don't really need lambda case. We don't need debug trace. Anything else HLint is mad about that I agree with, unlike this? No. Oops, wrong switching thing. Day 17, part 1. Cool. Let's check out part 2. Just tell me it's run it 1,000 times. For some reason, your simulated results don't... Oh no, it's a 4 spatial dimension thing. Okay. Any of the 80 other cubes... Yeah, okay. So this still makes sense. But it's the same deal about neighbors. You want like 2 or 3 kind of thing? Ugh. Oof. Oof, oof, oof. This is something that Haskell is a little bit like not great at. Is that the tuple types, like a 3 tuple and a 4 tuple, are completely unrelated types. They don't have anything in common, and so it's really hard to reuse something that works with 3 tuples to work with 4 tuples. We could parameterize our cube by its coordinate type and also include a function for finding neighbors, basically, and increasing size. So, but it still looks at 2 or 3 neighbors, right? I don't know, they don't say so explicitly, but I assume so. The same rules for cycle updating still apply. Consider the number of active neighbors of each cube. Okay. So should live doesn't need to change. Neighbors will have to change a little. Now, is this the kind of thing where we want a type class? It does seem useful, right? So that we don't have to pass in like 2 or 3 different functions. Yeah. Let's define a class. We almost want our class to be coordinate, don't we? And we'll replace this type for coordinate that's hard-coded to this. And our cube will be parameterized by... Okay. Class coord where... or you're supposed to class coord A, right? Or C, I guess. Yeah. We have a function neighbors is a function from C to list of C, and let's say plus is a function from C and int to C. Int to C to C, I guess, is a little cleaner. And I think that's all we need. Let me look up what types are in indexable, by the way. Okay, they did up to 3 and 4 tuples for me, so that's fine. So we don't have a coord anymore. We just have a C that we will have to enforce to be coordinable later. And we'll define instances for instance coord int where plus is easy, right? Plus n x y z equals x plus n y plus n z plus n. And we can just do this, I guess. It's a little bit gross to rewrite exactly the same thing for 4 tuples, but oh yeah, this is illegal. This would work for any number, right? Yeah. This is num a coord of AAA. Fine. What? What's wrong with flexible instances? First of all, I already... To really do this correctly, according to like Haskell 98 standard, I should define a new type for a tuple where all 3 element types are the same. Because tuple is a 3-argument type class, and you're not like allowed to say, oh, they have to be the same. But okay, you're right. We'll just add flexible instances to the top, and that'll be fine. I don't mind. And instance num a chord a where plus n xyz w equals w plus n neighbors of xyz w equals w plus dw, put a dw in here, and give this an old 4 instead of a 3. These are both getting a little bit ugly, so we'll indent this, or give this a new line. Ew, really? That's how you indent it? How about... I guess that's not as bad. Neither of them is great. Okay. Now, tick needs a little change. It needs to be chord C, cube of SC, cube of SC. And now we can throw away the X-min, Y-min, and Z-min and all this shit, right? That's actually quite nice. I think. We may need one more function in our type class to say, oh no, hang on, because it's indexable, we can use index to tell me, oh, I shouldn't have had to do this at all to begin with. Look, in index, you can say, given a low and a high, give me a list of all the ranges, of all the indexes within that range. And so we could have, to begin with, just said, for each position between low and high, do something. So we actually made more work for ourselves by being too specialized. That's quite interesting. So yeah, throw away all of this garbage. Oh, I'm just so happy with that. Oh, hang on. Bounds prime equal when we look at get bounds, what type does that have? Get bounds. Does it return a tuple? It should, right? Yeah. A tuple of 2 indexable things. Okay. So we actually need more than just chord C. We need index C as well. Which is great. We have that. Our tuples are indexable. We don't have to do anything new to make them indexable. So let bounds prime equal we do have to do a little bit more work here. Bounds low high equal what did we call our thing? Oh, plus low minus 1 plus high 1. Let's import in range and range now. We'll need range shortly. Okay. And now instead of this monstrosity, we can just say range low prime, high prime. And range takes a pair, or yeah, it takes a pair actually. Oh, so I don't need these. I can just pass it the whole bounds. Bounds prime. And I need a closed pair in there. Neighbor's coordinate. Okay. That looks fine. There's definitely stuff wrong in the file, so I'm a little nervous about the fact that I'm not getting red markers anywhere. Here we go. Now, this is where it's mad. Like, coordinate does not make any sense. Ah, that's an interesting point. We can't easily share between part 1 and part 2 because they're taking different types now. Interesting. Question about indexes for int. Yeah. So if A and B are indexable, then a tuple of A and B is also indexable. So we could just say it's a tuple of a 3-tuple and an int, and that would be indexable. But it would not currently be a valid coordinate here. We could change our instance to take like a 3-tuple of A tupled with another A, but that just seems gross. So I think what I'll have my input be is, gosh, it would be so nice if Haskell's tuples were something you could generalize over, so that I could say, oh, just give me like a number, which is my dimensionality, and then run it that way. But I don't think I can easily do that. So instead, I think my input will just be vec3, let's say, is int. And my input will be vec3, vec3, vec3. And now part 1 will still type check. Test is junk. We don't need it anymore. But part 2 still needs to actually be written. And what we will need is a function type vec4 int. Actually, it doesn't even need a type, right? We're only going to use it once. And we need 3, let's call it lift. We're not using that from any other package. Lift is a function from vec3 to int. Lift of xyz is just xyz0. No problem there. And so part 2 will just lift all the inputs it gets before doing exactly the same part 1 does. Which means that the information in part 1, almost the entire implementation of part 1 could be reused. It just, instead of taking an input, it takes something indexable and coordinable, right? So let's say we did this and called it run. Takes an indexable C and coordinable C, coordinable C, and then takes a, let's see, a tuple of pair of C and list of C, and produces an int. Look at that, it type checks. And so part 1 can just be run, right? line 45? Where? Couldn't match int with C. Okay, why? Oh, I forgot. I put the number first. Still wrong on line 26. What's wrong? Here? Oh. Yeah, that's true. It does only work for ints, doesn't it? Well, I can just make it take an A. Or a C. No. So the problem is our coordinate type promises to work for any number, but it actually only works for ints. Okay, fine. Let's just say it works for triples of ints. And we'll need like flexible context, we already have it, so that's fine. What are we not using from here, by the way? Get a soaks. Oh, that was only used by test, okay. So part 1 is run. Part 2 is still like do nothing. So let's see if we can still run part 2. Part 1. I'm not using lift A3 anymore either. 267. Was that the answer I got? It's close. 267. Yes, that was the answer I had. Okay. So now what I want to do is just say part 2 of low, high, alive, let's say, equals run of lift low, lift high, map lift alive. Right? Close parent. Compiles. Let's run it. It's a number, 1812. That's the right answer. Great. Once again, the first time we ran it, it worked. We can't always be so blessed, but today it worked out. Let's get rid of lift A3 because we didn't need that either. And I don't know. I mean, we don't use type classes a lot. I don't often say, gosh, I need a type class. That's something that like newcomers to the language who are used to object-oriented programming languages say. Anytime they need to generalize something, they say, I need a type class. Whereas usually you just need like a function. Or a record holding a couple functions or something. But here it seemed right to avoid passing like these two functions through to tick, basically. Like you could do it. You could there's little enough work here to do that I think it would not be very hard. Well, it would be harder to generalize run, right? Then run would need parameters for each of these things, right? It would need like a neighbor. So like, you know, we just let Haskell do the lifting for us and said, here's these two types I care about, and here's functions associated with them. I wasn't able to reuse as much as I would have liked, but I think that's okay. I don't know if I had. It still seems kind of sad that like in some sense, wouldn't this have been better to say that any tuple is an instance of coordinate? Any tuple of ints or something, I guess. And that way, like, we could, instead of having a for tuple, have like a tuple of an int with a tuple of an int with a tuple of an int with a tuple of an int, like, you know, which is kind of what? But that's kind of functionally equivalent, right? If we look at, you know, int, this type is equivalent to a for tuple of ints. And because of indexable and all this stuff, Haskell's arrays are happy to treat this exactly the same way they would treat a for tuple of ints, and they just like figure out how to lay it out in memory, and then they lay it out as a linear contiguous block, and that's fine. So it seems like it would have been nicer to say an int tupled with anything coordinatable is also coordinatable. And also, just a single int is coordinatable if we wanted. I think that might have been pretty nice. But it would have been a little awkward down in part 1 and part 2, where we like turn our 3 and 4 tuples into this really awkward notation. So I don't know, whatever, it's fine. Just like some stuff we could have done a little differently. That's all. Oops, don't delete that line. So did we do anything here that I want to like back out? Nah, this all looks good. Day 17, part 2. Cool. Okay, well, I hope you guys enjoyed that. Thanks for watching, and I'll see you next time.